Modification of single ball transmission drive. Abstract. Now the industries in all the field are moving towards the smart engineering, especially in the era of manufacturing, that also the conventional machining or traditional machining processes. These processes requires the high degree of accuracy and precision of the work, which is only possible by means of smooth and slow machining done by continuously variable transmission, CVTs. Continuously variable transmission is difficult to achieve by means of conventional drives like gear, belt, clutch, coupling. Here we are designing the system which will give the continuously variable transmission by means of single ball arrangement or mechanism. Keywords: disc, single ball, mild steel frame, bearing house, pulley, prime mover, belt, shaft. 1. Introduction. Nowadays industries are totally focusing on precise and accurate machining of components, parts, and job which have too much complexity while machining. This era is about industry revolution which come to 4.0 to 1.0, 2.0, 3.0, and all. So, in industry 4.0 is totally based on software and information technology tool for monitoring and controlling of manufacturing process in industry like turning, facing, drilling, milling, tapering, chamfering, boring, grinding, etc. Till date today we are using the transmission drives for the machining process to control the speed, feed, accuracy, and to define the precise components. Basically, the transmission in machining involve two motions. 1.1 Primary transmission motion. Primary motion is basically mechanical rotary or reciprocating motion. In case of machining process, the primary motion approaches tool as well as the moment of workpiece with respective directions. Due to primary motion, actual cutting forces are produced and the material from the workpiece removed easily. Primary motion consumes nearly 70% of energy of whole machining operation. Primary motion transmission is given as below. 1.2 Auxiliary transmission motion. As per name suggests, auxiliary uses alternative transmission which has no direct contact or relation for metal removal during machining. It include non-cutting motions which are carried quickly and easily. Auxiliary motion helps to 1. Reduce the labor cost. 2. Reduce production cycle time. 3. Increase productivity. 4. Loading and unloading job. 5. Motion synchronization according to shape and size. 6. Monitor and control the motion according to process or method, operation. 2. Principle of operation. 2.1 Single ball transmission drive. Single ball transmission drive works on the principle of continuously variable transmission, CVT. In such transmission, a device or mechanism is designed in such a way that speed reduction or acceleration of speed achieved continuously with respective of time, operation, or process. Fig. 2.1 shows an adjustable spherical ball inside the hub of a huge bearing which cause the axial movement of the ball. Input shaft and output shaft are connected to the spherical ball through cast iron disc having some curvature in order to reduce the percentage of slip and power loss during operation. Input shaft is driven by prime mover, i.e. primary motion or electric motor through belt and pulley, and whole assembly was installed within fixed frame. The ball is kept in oil casing for better lubrication. 2.3 Working. As the motor shaft that convert the electrical energy into mechanical rotary motion is given to input shaft, I, and hence the ball is connected to input shaft so that the ball also start to rotate, which cause the rotation of output shaft due to relative motion between them. As the ball is kept in oil casing, the average percentage of slip, power loss, and level of noise produced is minimized. 1. To reduce the speed and torque. As the lock nut mechanism attached to the ball assembly, as the nut is rotate clockwise, which will lower the ball, hence the speed is reduced due to more radial distance through periphery of ball, hence speed and torque transmitted to output shaft. 2. To increase speed and torque. As the nut is rotated in an anti-clockwise direction, caused to move the ball and upward, hence the disc are eccentric, so the radial distance of rotation through periphery of ball reduced, hence the speed increased. 3. Design and experimental setup nomenclature. A. For shaft. P equals power of the input shaft in watts. N equals speed of shaft in RPM. T equals torque transmitted by the shaft in Nm. B. For bearing. D equals inner cage diameter. D1 equals outer cage diameter. B equals width in mm. 3.1 Design of driver motor. 3.2 Design of shaft. Referring to American Society of Mechanical Engineers, ASME, design of shaft is done. Since the load on the shaft is mainly due to the machinery which is not constant, it is very necessary to take proper tolerances and allowance in order to bear the load fluctuations. According to ASME code, permissible values of shear stress, Fs, may be calculated from the following relations: F max equals 0.18 times Fut, ultimate tensile strength. For safe operation, select the diameter of shaft which is maximum. To achieve the tolerance of H6 H7 on the pulley, we need to bore the pulley hole, and the minimum hole possible is 16 mm, so adopting the shaft diameter 16 mm. 3.3 Angle of response. 4 Software result in analysis. Strain analysis. Strain is the reaction of a framework to an applied pressure. At the point when a material is stacked with a power, it creates a stress, which at that point makes a material distort. Building strain is characterized as the measure of disfigurement toward the applied power isolated by the underlying length of the material. Stress analysis. Stress examination is an essential undertaking for mechanical, plane design specialists associated with the structure of structures, all things considered, for example, burrow extensions and dams, airplane, mechanical bodies, and even plastic cutlery. What's more, staples. Stress examination is likewise utilized in the upkeep of such. 5. Conclusion. Firstly, most of the industries use a CVTs for their operation, which is difficult by means of gear, belt, rope, chain drive. Because gear levels to heavy impact while varying speed. Belt and rope have huge amount of slip and wear, hence we observed such problem and designed the mechanism for continuously variable transmission, CVTs. This mechanism enables the machining operation at various velocity and having stepless, shockless speed variation along compact size and most efficient to economy. From the test result from software and experimentally, it can nearly achieve 75% of efficiency at high speed.